Hello, my name is Principal Singh. I am Professor of Physics. Today we will study velocity time graph. Here on the board it is shown a velocity time graph. You see that this is the velocity time graph for a particle which is moving along a straight line. From this graph, the information that we can calculate is we can find out the instantaneous acceleration and we can find out the average acceleration. We can also find out displacement and average velocity and distance and average speed also. Let's see how we can find these things. First of all, I'll tell you how to find out the instantaneous acceleration. The instantaneous acceleration is dv by dt, that is the first derivative of the velocity, which is the slope of velocity time graph. The slope of the velocity time graph means if we draw a tangent on the velocity time graph, then the tan of theta, that is the angle that tangent is making with the horizontal, with the x-axis, tan of that angle gives you the slope. So the slope of the velocity time graph gives you the instantaneous acceleration. Over here you see that here the theta is acute angle, so the slope is positive. At this moment you see that the slope is 0, that is dv by dt is 0. At this point the slope is negative. You can see like this. This is the angle which is made by the tangent with the x-axis. So theta is obtuse angle over here. Therefore we can say that the slope is negative. At this point the velocity is becoming 0, and at this point you see the slope is again 0. So when the slope becomes 0, the velocity either is maximum or its minimum. Now how to find out the average acceleration? By the definition we know that the average acceleration is the change in velocity divided by time taken. Let's say for example the velocity at time ti is vi and the velocity at time tf is vf. So the change in velocity is vf minus vi divided by time taken is tf minus ti. This gives us the average acceleration. For example, if we want to write down the average acceleration from the time interval t1 to t2, so it is given by a average equal to the velocity at t1 is shown, it is v1. The velocity at t2 is shown, it is v2. So change in the velocity is v2 minus v1 divided by the time interval, that is the time taken, it is t2 by minus t1. So this is the average acceleration from the time interval t1 to t2. Now how to find out the displacement or the average velocity? The displacement is integration of v dt from ti to tf. This is the displacement of the particle from the time ti to tf. The geometrical interpretation of the integration is it gives us the area under velocity time graph. So this is the velocity time graph, and let's say we want to find out the displacement of the particle from t1 to t3. So how to find it out? Just find out the area under vt graph from t1 to t3. We will get the displacement of the particle from t1 to t3. Over here the displacement is positive. If you see at this point the velocity is going to be negative here. On this side of the graph the displacement is negative. It means that the particle is coming back. At t equal to t4 the velocity becomes 0, that is the particle has come to rest for an instant. After that the velocity has become negative. The graph has come down, which says that the velocity is negative and the particle is coming back. So hence we can say that this area is negative. We can also find out the distance and average speed also. For average velocity, you find out the displacement of the particle and divide it by the time taken. Let's say we want to find out the average velocity of the particle from t1 to t3. For that, we have to find out this area, that is the area that I am shading over here. This shaded portion area we will find out by the geometry or by integration, and then we will divide it, this area, by the time interval, which is t3 minus t1. So this gives us the average velocity. Now how to find out the distance and the average speed? We know that the distance is the total path length travelled by the particle. On this side, the particle is moving in the front direction, that is up to time t4, the particle is going in the straight line. After time t equal to t4, it is coming back because the velocity is negative. But the distance is the length it has moved in the front plus the length it has moved in the back. Therefore, we have to add these areas. We can find out the distance travelled by the particle. If we divide it by the time taken, then we will get the average speed. Today we will discuss a numerical which is based on a velocity time graph. The velocity time graph for a particle which is moving along a straight line. Here it is shown the VT graph, and we have to solve following problems. We have to find out the displacement and the average velocity of the particle from t equal to 0 to t equal to 10 seconds, and from the starting to 14 seconds. Then we have to find out distance travelled by the particle and the average speed from starting to t equal to 14 seconds. Then we will find out the average acceleration from t equal to 1 second to t equal to 10 seconds, and t equal to 8 seconds to t equal to 11 seconds. And finally, we will calculate the instantaneous acceleration of the particle at the various time, which is t equal to 1 second, t equal to 3 seconds, t equal to 9 seconds, t equal to 11 seconds, and t equal to 13 seconds. So we will start with the basic definitions that we know about the displacement, as we have learned that the velocity time graph, when it is given, the area of the velocity time graph gives us the displacement. So here it is solved. The displacement of the particle from t equal to 0 to t equal to 10 seconds, you see that it is a trapezium. The area of this trapezium gives us the displacement of the particle from t equal to 0 to t equal to 10 seconds. So the area is half sum of parallel sides. This and this side is parallel. This is 10 and this is 6. Half sum of parallel sides into distance between these two parallel sides is 20. Multiplied by 20. This gives us 160 meter. It means that the particle has travelled 160 meter in the front because it is positive. This is the displacement of the particle from t equal to 0 to t equal to 10 seconds. After that, we will find out the average velocity. As we know from the definition of the average velocity is total displacement of the particle divided by the time taken. So displacement of the particle in these 10 seconds is 160 meter. When we divide it by 10, we will get 16 meter per second. So this is the average velocity by which the particle has travelled for the first 10 seconds. Then we have to find out the displacement of the particle from t equal to 0 to t equal to 14 seconds. After t equal to 10 seconds, the graph goes down. The velocity becomes negative. It means that the particle is coming back. When the particle comes back, the displacement reduces. So we expect that the displacement should be less than 160 meter. So the area under VT graph is again the area of the same trapezium, which is half 10 plus 6 times 20, 160, minus the area of this triangle. The area of this triangle is half 4 into 20. The 4 is the base, 14 minus 10, and this is the height, which is again 20. I have subtracted it. Why? Because the velocity is negative. So the displacement of the particle is 120 meter. The particle has gone 160 meter front, then it has come back by 40 meters in the next 4 seconds. So the displacement of the particle is 120 meters. The total time taken is 14 seconds. So we divide it by 14 seconds. We get 8.6 meter per second. This is the average velocity with which the particle has travelled for the 14 seconds. Then come to the distance. The second question, the distance of the particle, the distance travelled by the particle from t equal to 0 to t equal to 14 seconds, and then we will find out the average speed also. At t equal to 0, the particle is here, and we see that this is the displacement. 160 meters is the displacement of the particle in the front direction, and it comes back by 40 meters. Logically, we have to add for the distance 160 meter in the front and then 40 meter in the back side. So this gives us 200. That is this area plus this area. This is 200 meters. The particle is travelled a distance of 200 meters for the duration of these 14 seconds. If we divide it by 14 seconds, we get 14.3 meter per second. So this is the average speed of the particle, the 14.3 meter per second. On an average, the particle is travelled by speed of 14.3 meter per second during these 14 seconds. Then we have to find out the average acceleration from t equal to 1 to t equal to 10 seconds. We know that the definition of average acceleration is change in velocity divided by the time taken. So let's see the change in velocity. The velocity at 10 minus velocity at 1. From the graph it is clear the velocity at 10 is 0 and the velocity at 1 is 10. So it is 0 minus 10, the change in velocity, divided by time taken. The time interval is of 9 seconds. When we divide it by 9, so we get minus 1.1. This is the average acceleration of the particle from t equal to 1 second to t equal to 10 seconds. By this way we can find out the average acceleration for any time interval. For example, from t equal to 8 seconds to t equal to 11 seconds. For this interval we have to find out the average acceleration. The velocity at t equal to 11 seconds is, over here we see that it is minus 10. From the graph it is clear. The velocity at 11 is minus 10. And the velocity at t equal to 8 is 20. So minus 10 minus 20 divided by the time interval. The time taken is 3 seconds. 11 minus 8. So it is minus 10 meter per second square. Now we will find out the instantaneous acceleration of the particle at t equal to 1, t equal to 3 and these intervals, these times. We know that the slope of VT graph gives us the acceleration. So the slope of this line at t equal to 1 lies over here. The slope of this line is 20 divided by 2, that is 10. So the acceleration is 10 meter per second square at t equal to 1 second. At t equal to 3, you see that the slope of this line is 0. So a equal to 0 at t equal to 3 seconds. At t equal to 9, the slope of this line is negative, which is 20 divided by 2. This is 2, this is 20. The slope is minus 10. So a equal to minus 10 meter per second square at t equal to 9 seconds. At t equal to 11 seconds, you see that this is the same line. The line has the same slope. So over here, the slope is also the same. That is minus 10 meter per second square. And at t equal to 14, you see that the slope is 10 again, but it is positive because this line makes acute angle with the x-axis. So the slope is positive, so the acceleration is positive. Thanks a lot.